Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's other type of puzzle, and it's supposedly easy level difficulty, but take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's other type of puzzle is called Fillominairrow. Fillominairrow. I think that's how you pronounce it. It's combining Filomeno with Perros, which is why it's Fillominairrow. And it's by the peddling pianist. Here are the rules. We have Filomeno, where we need to divide the grid into orthogonally connected regions. What is an orthogonally connected region? It's a region where you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region. This would be an example of an invalid orthogonally connected region because these two cells, even though they can connect to each other by going through edges while staying within the region, they cannot connect to the other cells in the region just by going through edges while staying within the region. They either have to go through a corner or they have to go through an edge, but go outside of the region to do so. So that's an example of how orthogonally connected regions work. We also enter a digit into each cell representing the size of the region to which that cell belongs in number of cells. So, for example, this region has 9 cells in it. So all the digits in this region must be 9, if that were the case. So if this were a valid region, since this region has 9 cells in it, it must have 9 in each cell. That matches the size. Regions of the same size may not be orthogonally adjacent. So for example, you could not have another 9-cell region sharing an edge with any cell in this region. So you could have something like 9 cells here, and this would be valid because this is a different region and doesn't share an edge with this 9-cell region. But you could not have something like this because then it becomes kind of too ambiguous of the problem. So regions of the same size may not be orthogonally adjacent, which means they can't share a cell or share an edge with any region that has the same number of cells in their region. And in this puzzle, there are no regions of size 10 or higher. So 9 is the largest region we can have. We also have difference pairs, where if a cell with arrows contains the digit D, then the cells D steps away in the indicated direction have a difference of D. So, for example, well, this doesn't work because you can't have a cell that's 9 cells away. But say this was a 7 here. That means the cells 7 away in each direction for the pairs has a difference of 7. So 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7 away would have to have a difference of 7. So you could have like 8 and 2, or 9 and... no, 8 and 1, or 9 and 2 in some order. You cannot have greater than 10, or sorry, size 10 or greater. And you can't have 0 because 0 is never going to be a digit in a region because you can't have a size 0 region. You have to have a size 1 region at most. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this cell can only travel one direction at most. Or sorry, go one way this way. So this has to be 1. And same with this. This is 1. This can travel 2, and it cannot be a 1 because of the ones that are neighbors with it. So this must be size 2. This can be up to 4 going that way. So this is 1 through 4. This goes 3 or it's 2. But the thing is, we know this is a boundary. This is a boundary. This 2 must be a 2 region going this way or this way. So this cannot be 2. So this is either 1 or 3 here then. This can go up to 4 this way. So 1 through 4. This can go up to 4 this way. So that's 1 through 4. This can go 1 or 2 this way. This can go 1, 2, or 3 this way. This can go only 4 at most that way. It cannot be 1 because it's next to a 1. This can go 3 at most this way, so it's 1, 2, or 3. This can go up to 7. This can go up to 1, 2, 3, 4, 5, 6. So this is 6 at most. This goes up to 1, 2, 3, 4, 5, 6. So we have 6 that way. And this can go up to 7. So we have up to 7. So 1 through 7 here. 1 through 7 here. 1 through 7 here. So the difference between these two cells must be... The difference between these two cells is 2. The difference between these two cells is 1. The difference between these two cells is 1. So that means it must go one way and then another way here. So what are the possible digits here? Obviously, you can't have 1. So it cannot be 1, 2. So this is 1 away or it's 3 away. If it's 1 away, these have to have a difference of 1. And it cannot... This would be 1, this would be 2, and therefore this would be 3 in that instance. If it's 3 away... That could potentially work. How do these work? These are 2 apart from each other. They cannot be 1. So you could start with 2. So you could go 2, 3, 4, or 2, 3, 4. 3, 4, 5, or 3, 4, and 5. Oh, these are different regions necessarily. Okay, so this is boundary, because those are 1. These are different regions. These are different regions. So this is going to be 3 or 4 at most. So we know this is either 2, 3, and 4, or 2, 3, and 4, or 3, 4, and 5. Okay. So this cannot be size 7. It has to be part of one of these 3 regions, right? Because it's blocked by these 2 in particular. So if it tried to be size 7, it has to extend out past these, and it can't be size 7 then. So this could be up to 5. Okay. May not be orthogonally adjacent. Okay. Can you have 3, 4, and 5 is the question. Maybe? Hmm. We know 2 has to be one of these two, which is why this can't be 2 there. Huh. Um. Huh. So what happens if it's 4, 3, and 5? We have 4, 3, and 5, because these must be 1 apart from each other, these must be 2 apart from each other, then these all become 4. You would have 4 away, 1, 2, 3, 4, and 1, 2, 3, 4 being 4 apart from each other, which is not going to work. So this cannot be 4. It has to be 3 here, and then this is 2 and 4. So this has to be part either 1, 2, 3, or 4. 4 away cannot be 4 apart from each other, so this can't be 4. 2 away does work. It's 2 apart from each other. But the problem is, if you have 2, that doesn't work. If you have 2 away, so 2 is definitely 2 apart from each other. But the problem is, if you have 2 as a region here, it must be 2, 2. This is 3, 3, but you don't have a third cell for this third region, for this 3-cell region. So this cannot be 2. So one of these is going to have to be 4. Okay. That seems fine-ish. So if this is 1, this has to be 2 and 3, because it must have a difference of 1. And it can't be 1 and 1 here, because they would be same regions sharing an edge. If it's 3, well, the problem with that, if it's 3, this cannot be 3. Because if that's 3, 3 away from 3 would only be 6. And none of these digits are 6. So therefore, it can't be a 6-cell region there, then. So it'd have to be, that's 1. This can't be 1. If this were 1, that would mean 3 is all of these cells, but then 3 doesn't have a... 3 and 3 has a difference of 0. So this cannot be 1. This must be 3. That's 3 in the corner. We celebrate because we don't know. I don't know. One of these is going to have to be a 4. You could have a 7 with it. So it's going to be 1, 4, 3 away. One of these is going to have to be 4 because it's going to have to extend out. So either this is 4 and 1 or it's 4 and 7. Well, this can never be 7 because it's surrounded by 3 cells, which none of which are 7. So this is 4 and 1, and this is 1, 4, or 7. So if we try to have a difference of 3, therefore it would be 3 and 6, and that's not going to work. So this must be a difference. This must be 1 away, which means this is 2, and it's a difference of 3 there. So 2 has to go to 2 there, and that's done as a region. We'll make these medium, medium, dark for 2. 3 will make green. This is 1. This has to have a 3, so it's either 3 that way or 3 this way. Yeah, it could be 3. So this is done as a region. Oh, this can't go to 7. So it's 1 and 4. Okay. Two can never go here. Sorry, 2 can never go out here. So this has to be a 2-3 pair here. We don't know which is which. So the 4 has to specifically go out, but we don't know where it can go to. This is 2, so 2 cannot be here. Can this be 1 away? You could have 2. If this is 1 away, that would force this to be 2 and this to be 3. And that's not going to work. So this cannot be 1 away. 2 does work. 1 and 3 is going to be 2 difference from each other. 3 could work if this is 6. That's potentially possible. 4 can 4 work if that's 2 or 3 and this is 6, 7, I guess. How about this one? If this is 1, this can't be 1. It's 4. It would require 3 to be here. And this 4 would not be large enough, so this cannot be 1. 2 would force this to be 4 that way. That's possible. 3 would mean these have to be 3 apart, which is not possible. 4 would mean these two have to be 4 apart, which is not possible. So this must be 2. So this is 2, which means these are 2 away from each other. So this is 4, which means this is 4, 3, which makes that 2 here. 4, we're going to make pink. 4 has to go out this way, so that's 4 here. This is then 3 apart from that, which is 1. So this cannot be 1 here. So this is a 1, a singleton. 2 has to be, let's draw borders around the whole thing. So 2 has to be there, 3 has to be there, 4 has to be here. 2 has to be here. So this is 2 here. We got 3 here. This is 4. So then this is 2, 2. This is 3. These are 4. So 4 away has to be 1, 2, 3, 4. That makes this a 6. Okay. 3 has to be one of these two. We're not sure which. 4 away. This could be 3. So this is done. This is done. So that's done. 3 away is 1 and 4. 1 away is 3 and 2. 1 away is 4 and 3. 2 away is 2 and 4. 2 away is 4 and 2. 4 away is 2 and 6, so that's done. 1 away is 2 and 3, that's done. 2 away is not a difference of 2. 3 away is not a difference of 3. Oh, wait, it's this way. Oops, not going that way. So 2 away would mean that's 2 and 4, which doesn't work. 3 away means this is 2 and that's 5. Or this could be 6 for 3 away from 3. So that's possible. That means this cell has to go this way because it can't be the 6. So this is border here. So we have that. So this is going, it cannot be 3. If it's 3, that means 3 is here, but the problem is that can't connect with the 3 here. So this has to be 4. So this is 4, which forces this to be 4 away from 3. So actually that's not 6, it's 7. So 4 has to be here, it has to extend out here. 3 definitely has to go to here at least. So this is 3 or 4 because it can't be 2. So this is green. This is pink going out that way. 6 has to extend out this way. So this is 6. We have boundary there. This is 4. This is 3 or 4. This is 6. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6 means this is 9. Interesting. So we're going to make that 9. This can't be 9, so this must go that way. So we have boundary there. This cannot be 1 away because this is a 9. So therefore, this must be some sort of region. So this is separate. This is boundary. Boundary 9 has to go to there, which means it must go to here. So this is 9. We have boundary here. This is not going to have a difference of 1. So this must have a difference of 2. So this must be difference of 2 from 9 is 7. 1 away is not going to have a difference of 2 and 7. It could be 2, but that would force this to be 9. Oh, 7, that does work. So this is 2 or 3. 2 away is not going to have a difference of 2, so no 2 there. 3 away could have a difference of 3. 4 away could have a difference of 4. Probably not, though, but 3 away has a difference of a certain amount. Probably 6 and 9. So 1, 2, 3, 4, 5, 6. And 6 would have to have a 9 there. So this is 2, and it could go this way. So this is 9 and 7. 7 or 6 away. Well, we don't have any of these defined, except for 2 and 1, which is why this can't be 1 or 2. This could be 2 away, and then you have, if it's 3 away, this would be 6. Would that be too many digits or too many? So we have 8 by 8 cells. We have 8 by 8, which is 64. We have right now 4 sets of 2. 4 sets of 2 is 8. 4 sets of 1, so that's 12. 2 sets of 3, so that's 6, 18. 2 sets of 4, which is 8 plus 18 is 26. 3 and 4 is 7, plus times 2 is 14. 2 and 1 is 3, times 4 is 12. 14 plus 12 is 26. Plus 6 plus 7 plus 9. I guess that could be okay. 13 plus 9 is 22. 26 plus 22 is 48. So we have 64 minus 48 left, which is 16. So we have 16 cells unaccounted for. So this could have actually another 6 there. Lovely. This has a difference of 3 or 4. So, well, 4 could go here. This cell cannot be 2 or 4. It could be 1, 3, 5, 6, 7, 8, 9. Obviously, it's quite a bit. Let's use these. So either this is 2 away, which makes that 9 and 7, or it's 3 away, which makes that 9 and 6. Can't be 7 away. 6 away would force us to be 3 and 9. We do have that ability. I don't know if that's going to happen. This is at least 3, so this must go down that way. So this has to go at least 3. Because it cannot be 1, it cannot be 2. Therefore, 2 has to go this way, which means this is 2 away. Which means this is 7 and 7. So this is the same region. Probably going to be the same region here. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 at least. So this has to go this way. So these are all 9. That means 7 has to go... Well, we don't know. It could actually be part of this. That could actually be 7. We just know that these two are the same. So this is done as a region. This is a boundary. 1 away could be 7 and 6 or 7 and 8. We don't know. 1, 2, 3, 4, 5, 6, 7. 3 away is 9 and 6. So this is 6. This must go out and connect, or this must share an edge with this cell. So this is part of this region. You could do something like funky like that. That is possible. So this is not guaranteed to have a 6. We do know that the 9 has to get out, though. So this is definitely 9 going that way. So this is part of this region. We have boundary here. 4 away does not work because that would be 9 and this would have to be 5. 5 would have to exit out here and these would not be a 6-cell region. So this must be 3. So this is 3, which means 3 away here has to have a difference of 3. So this is done as a region. This is green. 4 could go either here or here. If we had 4 go here, though, 3 away would be then... I guess it could be 7. Yeah, it could be 7. Or 6 and 9 also work. What can these digits be? So this can never be 1. Can't be 2 because then these would have to be 2 and that would be sharing an edge with this cell. So this can't be 1 or 2. Can't be 3. It can only be part of 7 or 9. So this could be 1, 7, or 9. Because it could connect 7 there. It could connect to the 9s. So this is 7 or 9. So 3 away has to be either 4 or 6. So So this is 4 or 6. Interesting. 3 away here is 9 and 6 there. So that's done. These obviously cannot be 3. 2 away is 7 and 7. Okay. This cannot be 7 away, because if this is 7 away, that would be a difference of 7. Oh, well, you can't have a difference of 7 with 3. You can't have 6 away either. That's 3, and then 6 away from 3 is 9. But then 9 would be trapped. So this can't be 6. 5 away. 6, 1, 2, 3, 4, 5 is not a difference of 2 and 6. So that doesn't work. 4 away, 1, 2, 3, 4 could work with that being 5. 3 away could work with 7 and 4, or yeah, 7 and 4. 2 away could work with 9 and 7. 1 away, maybe. I don't know, hard to say. We know this is a boundary. So this is yellow. 9 and 6. So 4 has to continue to one of those. That's fine. So this is done. 4 is done. Okay, can we do any of these? 3. 3 from 2 is not 7 or 9, so this can't be 3. 4 away from 4 could be 8. Maybe. That could work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 1, 2, 3, 4, 5, 6, 7, 8. That is possible. And you could have 7 here and then 9 here. So that is possible for this to be 4. So we know this has to continue on here. 7 does not work. 3 and 7 are not going to be that far away from each other. 6 doesn't work. 1, 2, 3, 4, 5, 6. 3 is not going to be 9 there. 5. Does 5 work? 4. So 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. That would force that to be 9. But there's no way we can get a 9 there. It can't be part of this 9, right? Because that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it has to be not part of this region. So we have 9. Again, you need 4 that way then. This would be 6 at least. 1, 2, 3, 4, 5, 6. These would be considered. 9 has to go here. And this is only 8 cells. So 5 does not work. Therefore, 4 must be the case. So this is 4. Obviously not green. It's pink. That's done as a region. This is all 4 then. This must be 4 away from 4. It's 8. So this is done. That leaves this as 8. And 8 cannot connect to here. 8 has to be essentially here. We don't have 5s, so... 7 and 9 have to... 7 and 9 have to be some combination of here. I guess 7 could... No, this is 7 here. So if this connects to this, it's 7. So this does have to connect to this. Right? Because this can't be 7 anymore. Or this can never be 7. So 7 has to go... If it's 7 here, As a region, it has to go here, which means they have to orthogonally connect. So this is all 7, which means this can't be 7 here. That's 9 and 9. So that's boundary. Um, 8 is boundary here. 6 is boundary here. This is either 4 or 8. This is either 6 or 8. And therefore, we have all 8s accounted for here. This is only so many, right? So we have one cell here is an 8. And then we have 4 of them are 4. And then the other 6 are 6. So this must be 6 here. Three away from this is 9. So 3 away from 9 is 6. So this has to be 6 here, which makes this 4, which makes that 8. So that's there. So we have boundary here, here, and here. We can color these in. This is orange. Okay, so this can be at most 4 here. No 5 or 6. Actually cannot be 4. If it's 4, the problem is this would be sharing an edge with another 4 region. So these cannot be 4. 1 away does not work here. 3 away does not work here, so this must be 2. So this is 2. 1 away works here. 2 away does not. 3 away does not. Right? 1 away it does work. 7 and 8 is a difference of 1. 9 and 8 has a difference of 1, but that's 2 away. 8 and 7 have a difference of 1. So this has to be 1 here. Therefore, this is 2, and this must be size 1. So let's do boundaries. These are medium, and this is dark. So this is 1. And that's how you solve it. I actually tried this earlier once, and I think I was too stuck on basically Sudoku habits. So I think I was eliminating 1, 2s, and 3s here based off of 1, 2s, and 3s in the row. Interesting. Very. I don't usually do Fillominairrow. I'm not the biggest fan of them, to be blunt. But I was curious how this would interact. And it seems to interact fairly well. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.